Now, so let's look at the products of electrolysis for multi-state binary compounds in a tabular form, in a more organized form. Let's look at the first one. If you look at this, they are all in molten states. These are the binary multi-state compounds. The first one is lead 2 chloride. If you look at it, as earlier said, this very one, Pb, Cl2, the ions Pb 2 plus Cl minus 2. This is a cation. It goes to the what? Cathode, and to be discharged as what? Lead. So here, all you're gonna have here is a lead. The half cell equation is just Pb 2 plus gaining 2 electrons. You look at the charge, you have this. So this is the cathode half cell equation. And likewise, the other one, this one, go to the what? Anode. And we get it as chlorine what? Chlorine gas. And you have the half cell equation. The extra electrons. That's the gas you obtain. So that's the first one, and that is the water discharge. So let's look at the ion 3. Now ion 3, the formula is this. Sorry, the bromine. And it's molten. What you have there is this. And you have Br minus 3. So ion will discharge. Right? And if you look at the equation, as usual, very important. Right? Then you have this. This one will go to the what? Anode. And at the anode, it discharges bromine. Right? You can write bromine vapor, or just simply write bromine. INE, not bromide, right? INE, right? That's in the free state. Neutral state, not chloride, not what? Bromide. ID is INE, right? For the mentals, it's just their name. So let's look at this. For that, you have Br. Sorry. Discharge, right? That would be the product at the what? As a product. That's the ionic equation, though the electrons here are not what? Balanced. If I have to do that, I have to teach you that, how to balance what that. But just know the product here is this, right? It's the bromine vapor, and this is what? Ion, right? Then the next one, if you look at this, that would be what? Aluminium. Aluminium. To explain aluminium, this is aluminium oxide. And it's molten. You have this. And you have this. Right? So this one go to the cathode, this one go to the anode. So here is just aluminium. And this is the discharge. That's very easy, right? Then the other one will be what? Oxygen. And that's it. If you have to discharge this, it's usually this to discharge is minus 4 electrons, right? I'll balance up later. It's not fully well, but just under oxygen. It's charged. Now if you look at sodium chloride, that's the easiest. It's the sodium, and that is it. And chloride, and that is the gas. So let's look at the general trend now. So you've seen that from the top to bottom, right from lead 2 chloride, iron 3 bromide, aluminum oxide, and sodium chloride. There's a trend, there's a pattern. You can see from the table that when electrolyte decomposes, a metal is formed at the word cathode. At the word cathode. Electrolysis, a metal is formed at the cathode. These are the metals: lead, iron, aluminium, sodium. Where? At the word cathode. That's a product. Also, if you look at and also a non-metal forms at the word anode. That's a positive electrode. Non-metals form at the word anode. See, this one of them. Bromines are all non-metal. Oxygen. Then here is what? Chlorine, right? Chlorine. Again. So all these ones are non-metal. Where do they form? At the word anode. That's general word trend. So from these you can always predict that metals are always formed at the word cathode or the negative electrode, and non-metals are always formed at the word anode. That's the positive word electrode. From these you can predict other molten state binary word compounds. They are just two elements there into their respective word element. So this you can different this trend that you can predict. This is only for what? Molten state binary word compound. You can use it to predict others given to you. I hope this is what understood. You can easily predict the product of electrolysis of a molten state word compound. Don't forget.